Welcome to day 2 of our SAT problems that involve geometry, things that we have seen this year. Your homework will be to finish pages 8 to 13 in the packet. We're going to do in this video all the way through page 11. So you'll have 4 problems which are on page 12 and 13. And within this period, you should likely have time to be able to do those and then submit them. Today's topic is right triangle word problems, so that means we're going to work with Pythagorean theorem, and we're also going to work with SOHCAHTOA as well. We will need our calculator for those, so be sure to have your calculator out. So first off, the homework ones from the previous day. So we wanted to start out, use our volume of a cone formula that's right on the formula sheet for SAT. We got 1/3 pi. Our diameter was 4, so radius was 2, and our height was 10. So when you do that, you get 41.887 and change. Well, they said they wanted the new height to be 8. So think of it as 1/3 pi. We don't know the radius squared times 8 for the height. And they want to know which of these choices for the radius is the smallest, but will have at least the volume of the other. So we just do it with trial and error. Start out, sub in r equals 2.0. When you punch that in, you get 33.5. Well, that's not at least the volume of the original one. We'll now sub in 2.3. You get 44.3. Okay, that is at least the volume, so 2.3 is our answer. We start from the smallest ones because that's what they asked for. They wanted the first one starting from the small ones that would work. So this is kind of a crazy looking picture, but it's really just 2 of the same pyramid with their bottoms stacked together. So your volume of a pyramid formula from your formula sheet is 1/3 the area of the base squared times the height. So 1/3, our base is a square, so 12 times 12, or 12 squared, times the height of 8.5. That's one pyramid. Then you got to multiply it by 2 because there's 2 of them. And then you get 816 millimeters cubed. Cylinder and a cone had equal volumes. So from your formula sheet, get your volume of the cylinder, pi r squared h. Volume of the cone, 1/3 pi r squared h. They told us the height was 24, so then let's set them equal. We can divide the pi r squareds over, and the pi r squared parts wipe out. Well, now h is just equal to 1/3 times 24, which will just give you 8 centimeters. Our dictionary, it's a rectangular prism, so we have length times width times height, but they told us the height was 3. That volume should equal 216, so divide the 3 over, and then the area of the front cover, which is the length times the width, would just be 72 inches squared. All right, this is on page 8 in our packets. Again, you will need your calculator out, and we'll give you a minute to read through the question. All right, so we want to find the distance between the players. The players were points A and B, so let's call that X. They tell us that the A is 25 yards from the sideline. So let's strategically draw that in here and label it 25. Well, now this length is going from the 12-yard line to the 50-yard line. So if you do 50 minus 12, that's just going to give us that this is 38. Well, notice this sets up a right triangle where we know 2 of the 3 sides. So we can just do Pythagorean theorem. So we'll have 25 squared plus 38 squared equals x squared. And we're going to give you a minute to go through and solve for this. Notice they want us to round to the nearest 1/10 of a yard. So give that a try. A box will pop up in a second for you to put in your answer, again rounded to the nearest 1/10 of a yard. So you should have gotten 45.486 and some other stuff for x. So the nearest 1/10, that's 45.5 yards. Moving down to the bottom of page 8, we'll give you a moment to read through this question. Once you've read through it, see if you can start to sketch a picture. So we have a rectangular baking sheet. So let's draw that in. 9.5 by 13 inches. So I'm going to do 13. I'm going to rate it as 9.5. And we want to know what's the longest breadstick that could fit on this baking sheet. Well, the longest that can be positioned would be along the diagonal here. So that's what we want to know. X. This is a right angle. So we should be able to set up Pythagorean theorem again. This is going to be very similar to the last one. So take a moment, see if you can go through and solve that. We're rounding to the nearest inch. And a box will pop up in a second for you to put in your answer after you have calculated it. So we should have gotten x is equal to 16.10 and change inches. So that's 16 inches to the nearest full inch, so choice B. Moving over to page 9. We're going to give you 30 seconds, see if you can read what's going on there. And once you've read it, start to sketch a picture. So we have a rectangular TV. It's got to fit between the windows, which are 36 inches apart. So the horizontal dimension has to be 36 inches. And we said it's twice as wide as it is tall. So if it's 36 inches going the long way, then this needs to be half of that, which would be 18 inches. Which of the following could be the diagonal length of the TV? Now keep in mind, what we've just drawn here is we've drawn the maximum size of the TV. If you wanted it to take up all 36 inches in between the windows. Can't have anything more than 36 because it wouldn't fit in the windows, but you could have something that is smaller. So if we do our Pythagorean theorem here, we'll have 18 squared plus 36 squared equals x squared. We'll give you a moment to punch that in and solve for x. So we should eventually get that x is 40.24 inches. So that's the maximum length of the diagonal. So we need our diagonal to be that or smaller, so the choice that would make sense would be choice A, the 32 inches. We'll give you 30 seconds or so, see if you can read through the scenario in the bottom of page 9. So based on the choices here, this tells us that we should be doing SOHCAHTOA. So just as a review, so we have SOHCAHTOA. So that's sine of your angle is always equal to opposite over hypotenuse. Cosine of your angle is equal to adjacent over hypotenuse. And tangent of your angle is equal to opposite over adjacent. So in Algebra 2, you're going to do a ton with sine, cosine, and tangent, usually at the start of the third quarter. So one thing to know here, we want to know the distance the water travels, so we can call that x, but we want to find that in inches. Right now, this 5 is in feet. So we can do 5 times 12, and that's going to give us 60 inches. But if you take a peek over at the choices, notice they've all got 5 times 12 left in there. So just so it matches up, when we set it up, we'll just leave it as 5 times 12 instead of writing 60. So from the angle, the 1.2, opposite is the one that's directly across, so this is our opposite side. Hypotenuse is across from the right angle, and adjacent is the one that is next to the angle but not the hypotenuse. So the two sides that we're working with, we have the A, and then we're looking for the hypotenuse. So that tells us we should be using cosine. So we'll do cos of our angle, the 1.2 degrees, is equal to the adjacent, which normally we'd write 60, but based on the choices, we'll write it as our 12 times 5, over what we're looking for, x. So we already know it's got to be either choices B or D because it's got cos in it. And we're going to put cos of 1.2 over 1, and we'll cross multiply. X times cos of 1.2 will just stay as that. 1 times 12.5 is 12.5. And if you divide by cos of 1.2, that gives us that x is 12.5 over cos of 1.2. So that looks like it matches with choice B. So this could be a no calculator question. Notice we didn't have to use our calculator at all for it. Okay, they would expect you to be able to do 5 times 12 without your calculator. Okay, we didn't even have to do it here, but based on the choices, but they would expect that. All right, go over to page 10, and we'll give you a little bit of time to read the scenario there. So based on the fact that they're giving us sine, cosine, tangent, that should clue us in that we should be doing SOHCAHTOA here. We want to find the value of theta. Theta is just a variable to represent our angles. From the theta, this is our opposite. This is across from the right angle, so that's the hypotenuse. Adjacent is next to the angle, but not the hypotenuse. So the ones we have values for are the opposite and adjacent. So based on our SOHCAHTOA, we want to use tangent. So we'll have tangent of theta is equal to 84 over 432. So if we look here, there's only one tangent one, so we're probably going to end up working with this. Take a second, do 84 divided by 432 on your calculator, and get it in decimal form. So we should be getting that it is 0.2. Well, notice tan theta equals 0.2 when we're trying to find theta. They told us here tan of 11.0 is equal to 0.2. So that means that we know that theta is equal to 11.2 degrees. Go down to the bottom, and we'll give you some time to read the scenario there. So we want to find the angle. So from the theta, this is our opposite. This is our hypotenuse, that's our adjacent. So we have numbers for opposite and hypotenuse, so we want to think sine. So sine of theta is equaling our opposite of 84 over the hypotenuse of 123. Well, we want to get to the theta. So the way we did that earlier this year is we did the inverse. We're going to do the inverse sine of both sides. So you end up getting theta is equal to sine inverse, which is the sine -1 of 84 over 123. But one thing we got to be careful about, they want us to round to nearest hundredth of a radian. We talked about in one lesson earlier this year that a radian is just a different measurement for an angle. We've up to this point usually used degrees, but a radian is another way to do it. So all we have to do is just change a little setting on the calculator. So on your calculator page, notice in the top right it says DEG for degrees. That means right now our calculator will measure all angles in degrees. Go up and click on that. And it should switch to RAD, which stands for radians. Now we know that our calculator is in radian mode. And we can just go ahead and do what we wanted to type in, our sine inverse of 84 over 123. So if you go to your trig button, go to sine inverse, do your sine inverse, and we'll just type in 84 over 123. And we get that. They wanted to the nearest hundredth of a radian. So to the nearest hundredth, the 1 tells us to keep the 5 the same, so we'll have 0.75 radians. Theta equals 0.75 radians. Okay, so just be cautious of that with your units. Now I would suggest for everyone to, on your calculator, let's go back and click that radian and switch it back to degrees. Because most of the time this year we'll be working with degrees, but that particular question we needed radians. All right, moving over to page 11. These are the last two we'll do in this video, and then we'll leave the last 4 questions for you to do on your own. So we've got some measurements here. We want to find the height. It's a right triangle. Notice there's nothing about angles in the problem, so that would rule out being able to do any SOHCAHTOA. We just want to think Pythagorean theorem. So we've got the 4.5 squared plus the h squared equals 11 squared. And we'll give you a minute to see if you can solve that. Notice they want us to round to the nearest foot in the end. So a box will pop up in a second for you to sub in your answer, again rounding to the nearest foot once you get it. So we should eventually get h equals 10.037 and change. So the nearest foot, that would be 10 feet. Moving down to the bottom of page 11, take a moment and read through that. So our height there is broken up into separate right triangles. Let's call this portion of it H1. And let's call this portion of it H2. Well, they both share this side, which is 145. In the top triangle there, the 145 is our adjacent, and the height is our opposite. In the bottom triangle, the 6 are angle there, the 145 still are adjacent, and the height too is the opposite. So if we're using adjacent and opposite, we want to use tangent. So in the top triangle, we're going to have tan of 17 equals our opposite, which is h1, over the adjacent, which is 145. We can do a similar idea in the bottom triangle. We'll have tan of the 6 degrees equals the opposite of h2 over the adjacent of 145. We can put each of these tans over 1 and we'll cross multiply. So h1 is just equal to 145 times tan of 17. And h2 is equal to 145 tan of 6. So to get h, we just need to add those together. So we'll do 145 tan of 17 plus 145 tan of 6. Now you have to be back in degree mode in your calculator because notice these angles were degrees. So make sure on your calculator page it says DEG. If not, click the RAD and switch it back to DEG. We'll give you a moment to punch this in. A box will pop up and ask you to select which of these choices is closest to what you got. So you should have got H was 59.57 and change. So that is closest. These are all to the nearest whole. So the closest would be our 60 meters. So choice C. All right, so that's all the ones we're going to do in the video here. So for your homework, you've got the next two pages, 12 and 13. When you upload that to Schoology, you can just take the pictures of pages 12 and 13 to upload that. And you should have some time left in the period to likely complete that, so then you won't have to do anything over the weekend. So just don't forget to upload it after you do it. Have a great rest of your day.